All right, here the recording in progress. So all right, I think I can finish 6.5 today. So we're going to knock this off. I'll do some problems that are here. Okay. So I would already be done, which means tomorrow I'll just go ahead and sneak in some of chapter 7. Now, none of chapter 7 will be on the exam. It's just a chapter 6 exam. Okay. So in terms of the schedule, I'm a little bit ahead. Okay, Thursday, I'll let you ask questions. Obviously, if you're not here, synchronously from 8:10 to 9, you can't ask any questions. You don't have to. But if the question, I'm letting you have Thursday for question and answers on anything from chapter 6, but if you don't have anything, I'll just go ahead and keep going. Okay, so first test again is on Friday. And review of some things. Coverage is right here, 6.1 and 6.5. Submit the homework. You must turn in at least 70% of the homework in order for me to count it. That's really a joke because I end up doing a huge percentage anyway, in which case you can just copy those problems. Okay, and again, if you haven't already shown me a photo ID of yourself, I need a photo ID because in a class like this, I don't get to know what everybody looks like. So just send me a photo ID of yourself. So a little bit past 8 o'clock, maybe like 8:02, 8:03, I'll send the exam on Canvas announcements, then you'll join the class synchronously. So I will take attendance. I'm not going to call the attendance, I'll just look down my, participation list on the Zoom call. So you have to join that day. All the other days are optional. You can just watch the video, but not for the exams. You actually have to be there. Have your camera on, true background. Don't have behind you, Golden Gate Bridge or outer space or something like that. Have your first and last name as on my row sheet. And if you have any questions, keep yourself muted. Any questions during the exam, send it to me on the chat. I'll close the Zoom at 9 o'clock. And then you have until 9:05 to submit the exam. And you have until 9:30 a.m. to submit the homework. But you can submit it early. Anytime after class Thursday, you may submit the homework if you wish. Okay, and now that you've sent in some quizzes, everything you submit to me is the same way. So just like you did the quizzes for the homework, just click, 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 email to me. And exam, same thing, click, click, email to me. Please separate the homework from the exam. So give me a separate email, one email for the exam and one for the homework, because if you send it all at once, I'm just looking at the homework and say, okay, you got the homework. I might miss the fact that you have the exam there. So one homework email and one exam email. If you send it in early, then that kind of takes care of that already. Okay. You can have one cheat sheet, again, one formula sheet. Write anything you wish, any formula, sample problems, 8.5 by 11, both sides. But beyond that, nothing else. You can use a calculator, but no other books or notes or people or computers or internet you can't use for the exam. I usually give about 10 questions. So let's see, we had 5 sections, so likely to be 2 questions per section. Okay, so 50 minutes divided by 10, that's roughly 5 minutes a question. So budget your time accordingly. Show all your work. I do give partial credit. Okay, so it is possible to get more points with an incorrect answer than you had a correct answer. So if you give me a correct answer, but I don't see any work, you might not get anything. But if you give me an incorrect answer, but your setup was good, I can follow your steps and say, oh yeah, you did this, 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 you just made a small mistake here. I could give you more points for an incorrect answer than for a correct answer based on what I see on the work. Okay, and keep in mind, I can always call you in individually if I suspect cheating. I might say, come join me on a Zoom meeting. I'll tell you if that happens. And then I'll say, okay, show me how you did problem 5 or show me how you did problem 2. And if you can't explain to me what you did based on what I saw written, then I may decide to give your oral score a higher priority than your written score, right? So that's the way that is. Okay, so check, does anybody have any quick questions about the format of the test and homework and exam? You can put together your cheat sheet, submit the homework. If you haven't already shown me your photo ID, send me a photo ID. I'm not going to grade your exam without a photo ID. I need to know what you look like. And for a class like this, as you know, I don't get to know what you look like. So how do I know it's really you that's taking it, right? if you show me your driver's license, all I need is your name and the photo. You can block out any, other sensitive information. I don't need your address, your age, your birthday, height, weight, and all that stuff. Just your name and photo ID. Okay. All right. So I'll go ahead with more of 6.5 and what you need. Right. So 6.5, page 461. Average value, f average, is 1 over b minus a, integral from a to b of f of x dx. I will write AVG for average. And there's something here on page 462. Mean value theorem for integrals. There's some homework problems involving it. Now you might say, do I have to write this on my formula sheet? I don't think you really need to. I'm not emphasizing that much, even though the homework has a couple of questions involving it. What does all of this stuff mean? Okay, so I would say it's optional to put it down. You don't really need to put it down, but what is it talking about? If f is continuous on the closed interval from a to b, there exists a number c in the closed interval from a to b, such that f of c is f average is 1 over b minus a, integral from a to b of f of x dx. Okay, what does all that mean? Right, so here's our function, it's continuous. This is the average value. So we said the area under the curve matches the area of this rectangle. This point right here, where the rectangle touches the graph, that's what they mean by C. Rephrasing of this, somewhere the average value touches the graph. If you stop and think about that, it's very logical. The average value isn't going to be at the top. The average value isn't going to be in the bottom. Average value has to be somewhere in the middle. That's all. And if you have a continuous function, then your average value touches the graph somewhere. Okay. Now, if I make a discontinuous function, like I go like this and then cut it off and go here, it's possible that the average value doesn't touch the graph. But in this case, it does. So this is what they mean by C. Okay. For continuous functions, which almost all the functions that we do are, okay, the average value touches the graph somewhere. So there are some homework problems involving that. All right, so I'll do some of these. These are relatively benign in my opinion. They're not as bad as all that. You're just going to integrate and make sure you divide by the length of the integral. Okay. All right, question 5. F of t equals e to the sine t cosine t from 0 to pi over 2. So the average value is 1 divided by b minus a, pi over 2 minus 0, integral from 0 to pi over 2, e to the sine t cosine t dt. Right? So this is an example of a u substitution. You might recall doing u substitutions at the end of Calc 1, perhaps. Here's a function. Here's just derivative. Okay. Derivative sine is cosine. By the way, you might say derivative cosine is sine, but you don't want to go that way because you don't really have sine. You have e to the sine. That's a little bit tougher. So that u be sine of t. If I make this u, you'll have e to the u, but I don't mind integrating e to the u. E to the u is easy to integrate. So u equals sine of t, du equals cosine t dt. So this stuff is going to be du, this is u. And I'm going to change the limits of integration. As t goes from 0 to pi over 2, what happens to u? So I plug in. Plug in t is 0. U is sine of 0, which is 0. Plug in pi over 2. U is sine of pi over 2. Sine of pi over 2 is 1 from trig. So f average is 1 divided by pi over 2. 1 divided by pi over 2 is 2 over pi. And I'm now integrating e to the sine of t becomes e to the u. And cosine t dt, change it to du. And my limits of integration now become 0 to 1. Okay. So remember, this was a u substitution. This is my u. This is my du. And I even changed the limits. T goes from 0 to pi over 2. U goes from 0 to 1. All right, and the integral of e to the u is itself. 2 over pi e to the u from 0 to 1. So 2 over pi, leave that alone. Plug in 1, e to the 1 is e. Plug in 0, e to the 0 is 1. So final answer is 2 over pi e minus 1. And that's about it for that one. Okay. All right, now number 9. I was going to show you number 10 also. Number 9, find the average value. Okay. Find C such that F average equals F of C. And it says sketch the graph. Okay. For number 11, let's not sketch. This graphing calculator icon means do it on a graphing calculator. It's too difficult to do this by hand. Okay, so for 11, say no sketch. You don't have to sketch it. Problem number 11. Yeah, don't worry about sketching it. All right, so f of x equals x minus 3 squared on the closed interval from 2 to 5. So the average value is 1 over b minus a, 1 over 5 minus 2, which is 1/3. And the integral from 2 to 5 of x minus 3 squared dx. This one I can just go straight to the power root. I don't have to worry about the chain rule because the derivative of x minus 3 is 1. Okay. It'd be a little bit more complicated if you had a 2x minus 3, or even worse if it was x squared minus 3, then the only thing you could do is multiply it out. But in this case, since the derivative of the inside is 1, you can just go to the power root, take blah, blah, blah to the 3rd over 3. So 1/3 x minus 3 cubed over 3 from 2 to 5. And I double check, what's the derivative of this thing? 3 comes down, knocks out that 3, x minus 3 squared, and then times the derivative of the inside by the chain root, but that's just 1. So it seems to work. All right, 1 over 3 times 3, so 1/9. Plug in 5. 5 minus 3 is 2. 2 cubed is 8. Minus, plug in 2. 2 minus 3 is -1. -1 cubed is still -1. So I have 1/9 of 8 minus a -1. That's 8 plus 1 or 9. 9 over 9. Answer is 1. So the average value is 1. Now, just to show you graphically what's going on, I know that this is parabolic. Vertex is at 3, 0. So if I plug in 2, I get 1, 3, 0. If I go to 5, I get 4. So the graph looks something like this. And here's the average value. Looks like it touches here and also here. So where's here, I set the function equal to 1. We're saying the average value is attained somewhere on the integral. So x minus 3 squared equals 1. X minus 3 squared is 1. Do the square root property, square root, plus or minus. X minus 3 equals plus or minus 1. Add 3, x is 3 plus or minus 1, which means x is 2 or 4. So I have 2 C values from this mean value theorem. The C value, where the average value is the same as a point on the graph. The 2 C's are at 2 and at 4. In other words, f of 2 is 1, f of 4 is 1. It could happen more than once, but it has to happen at least once by the mean value theorem integrals. Okay, so we found the average value to be 1. Is that average value of 1 attained anywhere on the interval? Yeah, right there and right there. And where's there and there? At 2 and at 4. That's all that means. Okay, and I'll do 10. I know it's an even one, but it's a good problem nonetheless. F of x equals 1 over x on a closed interval from 1 to 3. So the average value is 1 over b minus a, 1 over 3 minus 1. Integral from 1 to 3 of 1 over x dx. Integral of 1 over x, ln absolute value of x, this is 1 over 2, from 1 to 3. Okay, plug in 3, absolute value of 3 is 3, so 1/2 ln 3 minus, plug in 1, ln of absolute value of 1 is 1. The natural log of 1 is 0, so So I just cross that out. So 1/2 ln 3 is my c, which I can write as ln 3 over 2. So now find the c value. Where on the interval between 1 and 3 do I get that average value? This funny thing of ln 3 over 2. Well, I take the function 1 over x, set it equal to ln 3 over 2. I can reciprocate both sides. If this is equal to this, you can flip them both. The flip of this, reciprocal of this, equals the reciprocal of this, which means x is 2 over natural log of 3. Punch it in your calculator, it's about 1.82. And 1.82 is between 1 and 3. So it looks like we're good there. So here's a rough sketch. We know what 1 over x looks like. 1 over x looks like that. So we found the average value to be, where'd it go? ln 3 over 2. Where does it touch? At this c value, which is reciprocal, 2 over ln 3. Okay, so 2 over ln 3 is between 1 and 3. It's about 1.82 if you punch it in the calculator. Okay, so that is that. Okay, we had some problems here. 13, if f is continuous and the integral from 1 to 3 of f of x dx equals 8, show that f takes on the value 4 at least once on the interval from 1 to 3. Okay, so that's just using the mean value theorem for integrals directly. Just let me write down the important data. It says the integral from 1 to 3 of f of x dx is equal to 8. That means the average value, f average, is 1 over 3 minus 1, integral from 1 to 3 of f of x dx, which is 1/2 of 8, and that comes out to be 4. Right, so, sorry, I can't show you both at the same time. The integral is 8. The average value is 4. You just take 1 over 3 minus 1, that's 1/2 of 8, which is 4. So f takes on the value 4 at least once on the interval from 1 to 3. And so by mean value theorem, you abbreviate theorem with thumb, by mean value theorem of integrals, f takes on the value 4 on the closed interval from 1 to 3. And that's about it. Pretty much just a rewording of the theorem. And when I say it takes on the value 4, it has to happen at least once. It may happen more than once. It can happen 2 times, 3 times, 1,000,000 times, but it has to happen at least once. Okay. 15, a little bit funny. Find the average value of f on 0, 8. So I know I'm going to be taking on 1 over 8. So I have to find the integral. So for the integral, I'm basically counting a bunch of squares here. Okay. So I'll just write directly onto my text, I don't mind. Okay, so this is below the x-axis, that's a negative 0.5. Negative, positive 0.5, positive 0.5. So it's hard to see that. Okay, what is this area there? Well, it's half of 2, so that's 1. That's 2, that's 2. 1.5. And 1 plus 1, 2. We're just counting triangles and squares and so forth. This is below the x-axis. Can't read that. That's a negative 0.5. Positive 0.5. 0.5. This is 1 because it's half of 2. That's 2. That's 2. That's 1.5. Here's 1. And half of 2 is another one. So 2. So the integral from 0 to 8 with f of x dx is equal to, just add them all up. Okay, these two cancel out. Point 0.5, 1.5, 3.5, 5.579. Okay, again, negative 0.5 and a positive 0.5 cancels out. I know what I'll do. These two here give me 2. 2, 4, 6, 8, 9. Okay, so negative 0.5 plus 0.5 plus 0.5 plus 1 plus 2 plus 2 plus 1.5 plus 2 equals 9. Cancels out 1, 3, 5, 7, and 9. All right, so I just divide by 8. So F average equals 9 over 8. The integral is 9. The length of the interval is 8. So 9 over 8. Okay, 17. I'll give you the setup, but I won't do the whole thing unless somebody wants me to later on. In a certain city, the temperature T hours after 9 a.m. was modeled by the function T of T. Okay, capital T is for temperature, little t is for time. Okay, so they're not the same variable. So temperature, time. 50 plus 14 sine of pi over 12t. Find the average temperature from 9 a.m. to 9 p.m. So we're talking about time since 9 a.m. So if we're starting at 9 a.m., that counts as 0. And 9 p.m. counts as 12. Okay, so I'll show you a little bit of the setup, but I'll etc. at some certain point. Right, so 50 plus 14 sine of pi over 12t from 9 a.m. to 9 p.m. I'm integrating from 0 to 12. The length of the interval is 12, so it's 1/12 integral of 50 plus 14 sine pi over 12t dt. Okay, so I have 1/12. Let me talk about the integral here. So the integral of 50 dt is 50t, that's easy. And let me talk about the chain root in reverse here. Okay, you know there's going to be a 14. All right. The integral of the sine function. What is the integral of the sine of t? Integral is negative cosine t, right? Negative cosine. So negative cosine. Now think of the chain root. If I ask to differentiate this function, sine of blah, blah, blah t, you would go cosine pi over 12t. Then by the chain root, it's times the derivative of the inside function, that being pi over 12. So I have to multiply by an extra pi over 12, right? Chain root. Okay, so think when I differentiate, I multiply by pi over 12. Therefore, when I integrate, I do the opposite. I divide by pi over 12, which is the same thing as multiplying by 12 over pi. Okay, so that's a little bit tricky. So this is what I want for the antiderivative. 50 pi. Okay, so minus 14. Okay, integral of sine is negative cosine because the derivative of negative cosine is positive sine, pi over 12t. And then by the chain root, if I were to differentiate, I would multiply by pi over 12. Since I'm integrating, I divide by pi over 12, which is the same thing as multiplying by 12 over pi. Okay, then I just say et cetera after that. After that, you just plug stuff in. Plug in 12, plug in 0, and so on. Okay, so it's a chain rule in reverse. Okay. Now that only works as long as you have a constant involved. So I'm finished with this problem. You're not finished with the problem. You finished the et cetera stuff. Just plug in. But you can ask me if you have any questions Thursday, I suppose. So a little bit of timeout practice here. So let's take e to the 3x prime. What's the derivative of e to the 3x? Well, e to 3x. And then by the chain root times 3. Right? So in other words, I multiplied by 3. So what do you think happens when I integrate? Well, you don't multiply by 3, you divide by 3, or multiply by 1/3. Excuse me. Like so. Right? Remember, how can you check your answer to an integration? Differentiate. What's the derivative of this thing? Well, the derivative of this thing, the derivative of c is 0. Derivative of this thing is the same thing times 3. Well, when you multiply by 3, that knocks out to 1/3, and you get e to the 3x. Perfect. Let's do a trig one. Trig, you have to be a little bit careful because of the SIGN difference. So how about sine of 5x prime. Derivative of sine 5x. Cosine 5x. And then by the chain root times 5. I multiplied by 5. So what do you think happens when I integrate? I don't multiply by 5, I divide by 5 or multiply by 1/5. So integral sine 5x dx. See, integral of the sine is negative cosine, so negative cosine 5x plus a constant. And then do the chain root. If I differentiate it, I multiply by 5. So when I integrate, I divide by 5 or multiply by 1/5. So that's what I want. Negative 1/5 cosine 5x plus c. Check by differentiation. What's the derivative of this thing? Okay. Derivative of negative 1/5 cosine 5x is positive 1/5 sine 5x, and then by the chain root times 5, that 5 knocks out the 1/5, and you get this. And of course, the derivative of any constant is 0. So it looks like it works. Right? Okay, and I need to emphasize that only works when you have a constant applied to the chain root, not for variables. Okay, so let's say if you have the integral, derivative of e to the x squared, e to the x squared prime, derivative is e to the x squared times 2x. Okay, since there's a variable involved, you can't do that same trick for integrals. In other words, you might say, can I divide by 2x? No, you can't. Okay. And the reason why you can't is just try it. Okay. You won't end up with the same derivative. You'll have to use a quotient rule and so on. In fact, this does not turn out to be something that's integrable by ordinary means. We're never going to know how to do this, sort of. We actually can tackle it in our last chapter, but in a strange way, and worry about it when we get to it. Okay, so anyway, that's what I was doing over here. Over here, if I differentiate it, I will multiply by pi over 12. So when I integrate, I multiply by 12 over pi. Okay, then I will go back and do number 1. I give you a fake number 1 before, but not the real number 1. 3x squared plus 8x on a closed interval from -1 to 2. And then I'm finished, folks. All right, so by formula, 1 over b minus a. Put this on your formula sheet. 1 over 2 minus a minus 1. And you go from -1 to 2. 3x squared plus 8x dx. So 2 minus a minus 1 is 1/3. Integral of 3x squared is 3x cubed over 3. 3's cancel out, you just have x cubed. 8x squared over 2. 8 divided by 2 is 4. -1 to 2. Remember, if you're not sure about this, you can always double check an integration by differentiation. Right? What's the derivative of that? 3x squared. What's the derivative of that? 8x. You know you got it right. And I'm going from -1 to 2. Okay, so 1/3. Plug in 2. 2 cubed is 8. Plus 4 times 4 is 16. Minus parentheses. Plug in -1. -1 cubed is -1. Plus -1 squared is 1. 1 times 4 is 4. So 1/3 of 24 minus 3. 21 over 3. Final answer is 7. And there we go. All right, so I'm officially done with the chapter, folks. Okay, so coverage of the exam is everything here. I can mark this off. Okay, so you are now responsible for all this. Of course, the test is not until Friday. Okay, I'll sneak in a little bit of an introduction of what's happening after that in chapter 7. I'll do a little bit even now. Okay, again, Thursday, I'll let you reserve all of Thursday for question and answer. But if you don't, I'll just keep going. I don't mind getting ahead. Remember last year, around this time, I lost a whole week because my internet was down the whole week. So I lost a week. So I'm planning for that by having little buffer days and so on. Okay. All right, so let me make this disappear. Just a real quick introduction as to what are we doing next. Chapter 7 is on techniques of integration. We're not doing the entire chapter. 7.1, 2, 3, 4, 7, and 8. We're not doing 7.5. We're not doing 7.6. Okay. So we're doing integration, integration, and more integration. 7.1, something called integration by parts. There's a formula for that. Okay, you're going to put this on your next cheat sheet, but don't worry about it for this test on Friday. Okay, I'll just mention in passing. Box 2 is the formula for integration by parts. So what about number 1? Number 1 is equivalent to number 2, but this looks a lot shorter. Right? I like shorter better than longer. So these really mean the same thing. This is the form that I'll be using most of the time. Starting tomorrow, perhaps. Section 2, we do trig integrals. Integrals involving trig functions, cosine, sine, secant, tangent, and stuff like that. 7.3, something called trig substitution. There's a table here that you'll be putting on your cheat sheet. Okay, so don't bother with it now. You don't need this for the test on Friday. So again, I'm just letting you know where we're headed. Chapter 4, we have something called partial fractions, whatever that means. You may have had that in your pre-calc, but not every pre-calc teacher goes over it, and they're not required to. So if you've never seen it before, don't worry about that. So this whole chapter is pretty much integration, 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 and more integration. Now, why are we skipping 7.5 and 7.6? 7.5 is called strategy for integration, which means it's just a review of 7.1 to 7.4. So you're not doing anything new. They do give you a table of integration formulas, okay, that you may have seen before. And of course, you're welcome to put as many of these on your cheat sheet as you wish. But remember, integration is just the opposite of differentiation, right? So they're just going backwards from the derivatives. So for instance, integral of secant squared is tan because the derivative of tan is secant squared. right? Integral of sine is negative cosine because derivative of negative cosine is sine and so on. Okay. So that's why I'm skipping 7.5. 7.6, integration using tables and computer algebra systems. Okay. That means you need a fancy computer with software. Okay. Well, I'm not emphasizing tables and software, so that's why I'm skipping 7.6. 7.7 is on approximate integration. There are some integrals which cannot be done easily or they're impossible to do. So we can only do approximations of them. And finally, 7.8 is on something called improper integrals, which leads you to believe that everything we've been doing right now is proper integrals, right? You've heard of proper fractions and improper fractions. So you can have proper integrals and improper integrals also. Okay, and we'll learn something about improper integrals. Okay, so that's the basic idea of what's up on chapter 7. It's basically an integration chapter. So the next chapter, next test is all about integration. Okay, so that's what's going on there. So tomorrow I'll start sneaking in a little bit of 7.1, something called integration by parts. It will not be covered on Friday's test, but since I'm a little bit ahead, I might as well go ahead and get started with that. Okay, other than that, I'm finished for today, unless anybody has any questions about anything. Okay, so if anybody wants to ask anything, you may now. Let me stop the share, check the Zoom, the chat rather. And if not, we're done. Okay, so anybody with a question?
Yeah, I have a question. Can you hear me, Professor? Do you have an office hour today from 11 to 12 or no?
I do not have office hours from 11 to 12.
Okay.
I'm teaching another class.
Got it. Sorry about that.
Yeah. Okay. All right. Anybody else with a question, please? All right, then that'll do it for today. All right, so have a good everybody, and we'll see you next time. Okay.
Thank you.
Take it, Professor.
Thank you.